In this group assignment, our group chose application of differentiation part 3.2 related rate. In this video, we will tell you what is differentiation, why we use differentiation, importance of differentiation, related rate, problem statement, problem solution, conclusion, and reference. Our friend Amira will explain to you step by step the problem solution in this video. What is differentiation? Differentiation in mathematics is the process of finding the derivative or rate of change of a function. That is the symbol that will be used for differentiation.
Why do we use differentiation? Differentiation allows us to find rates of changes. For example, it allows us to find rates of change of x with respect to y, which on graph of y against x is gradient of the curve. We also can find the rate of changes of velocity with respect to time, which is acceleration. The importance of differentiation. It can help us solve many types of real-world problems.
The objective for related rates is to find the rate at which one quantity is changing by relating to the other quantities whose rate of changes are known. Okay, for these related rates, you need to know step by step before you solve the related rates problem. Okay, first step for related rates is identify. For identify, you should draw a picture of the physical situation and you will be able to imagine and get idea for the question. You also should find with respect to time. Next step is find the equation. First step for find equation is be sure to label as a variable any value that changes as situation progresses. Don't substitute the number for it yet. The next step for find an equation is to develop your equation. You will probably use a simple geometry fact like the relationship between a circle's area, which is pi r square, and its radius, or the relation between the volume of cone, which is 1 over 3 pi r square h, and its base, radius, and height. The step is differentiate step. You should differentiate equation in step 2 with respect to time of both sides. You should remember the chain rule because in these related rates, chain rules are often used for differentiate. The next step is substitute. Substitute the known value obtained in step 2. For example, if we got value of R for the volume of cylinder, you just substitute R to the volume formula for cylinder. Then the last step is you should solve the problem. In this last step, you should solve the remaining of change, just remaining of the change.
Problem statement. A spherical balloon is inflated with gas at the rate of 800 cm³ per minute. How fast is the volume of the balloon increasing at the instant when the radius is 30 cm? Please try to understand the question and write what important. Problem solution.
The given information is dV over dt is equal to 800 cm³ per minute. So the next step is we need to know the volume of spherical balloons. So V is equal to 4 over 3 pi r³. So r³ is equal to 3V over 4 pi. So the next step is we need to differentiate with respect to the time to time, we need to use implicit differentiation. We need to apply on each side with respect to the time. So the last solution is we get dr over dt equal to 3 over 4 pi 1 over 3 r square dv over dt. So to find how fast the volume of the balloon increasing at the instant when the radius is 30 centimeter, the equation that we get early, we need to substitute r equal to 30 centimeter and dv over dt is equal to 800 centimeter cube per minute, and solve the equation. That the last is we get 200 per pi r square, and we need to substitute r is equal to 30 cm. So the last one is 2 over 9 pi centimeter per min. The answer of how fast the radius of the balloon increase.